We will often encounter data from primary or secondary sources that will have missing values, maybe because of data not available or human error. So in this lab session, we will learn how to treat the missing values. And this technique can also be applied to correct the outliers, that is the extreme abnormal values. First, we will see how to identify and save the positions of missing value in the dataset. is.na is a generic function that indicates which elements are missing. It uses a logical indicator true, false to indicate the missing values. Load a sample data with na.strings is equal to the list of missing value formats. In this case, we will indicate R to treat space and na as missing values while loading the dataset. Now, we will use is.na to impute the missing values. Okay, if we simply use is.na, it will give true or false to indicate the positions of the missing values. Using this with another function like sum will give the total count of false, that is the missing values. Now, before we move forward to fill up the missing values, let me give the list of how to calculate a value to impute the missing values. Of course, we can't simply replace the missing values with any values, which in turn will compromise the integrity of the data. First of all, there are two simple ways. If we are aware of the missing values, we can directly impute the value for all the missing values, like this, where transamount3 is the column name. Else, we can also use the average value to impute the missing values, where na.rm indicates R to remove the na values and calculate the mean, because the mean cannot be calculated with the missing values. Now check using summary function. Done. We don't have any missing values. Next is a detailed approach to impute the missing values. For numeric variable, in this case we will use transamount2 column. First, we will get a quick summary of the data distributed for the transamount2 column. Even visualize the data distribution to get a clear picture using box plot. Further, break up the data distribution in percentage using Quantile. 25%, 50% and 1, that is 100%, with na.rm is equal to true. From these three methods, we are getting a clear picture that half the way of the total data, the average maiden value is 20. Then at 75% of the average value is 85. So almost 75% of the data contains an average value of 20 plus 85 by 2 is equal to 52.5. Before we conclude an average value for the missing values, let's do a sanity check. In the box plot diagram and the summary, there is a sudden spike in the values from 85 to 6783, which looks very unusual. Common reason behind this is a chance of a human error. So let's remove the outlier and redo the steps to see any changes. Saving the positions of the values whose transamount is greater than 2000. That is the outliers. Now, after removing the outliers, we can see the max value is 1938. Again, let's visualize the distribution if it is evenly distributed or not. Break up the data distribution. OK. Detail 10% data distribution. We still can see the pattern of the data distribution remains the same. Therefore, we can conclude that 75% of the data contains an average value of 52.5. Now, we can confidently impute an average value 52.5 for all the missing values. Rechecking using sum. Now, we don't have any missing values for the transamount2 column. Now, let's see how can we do the same for character or factor variables. For this example, we'll use the department column. Let's check how many missing values. Summary mdata $department. Or we can also find the frequency of each factors of departments using table. Convert the table 1 that we just created into a data frame. I prefer to save it in another R object in case if you have to go back to the original table 1 data. View the data. We can see we have frequencies, that is the number of occurrences for each factor variables. Now we will add the rate of frequency for each factors of departments. Now using the quantile, we can see that 25%, that is the 1/4 of the data, occurred approx 1500 times. Let me explain using this table. See here, number of departments with 1500 almost looks 25% of the whole table. Then approx 2500 occurrences up to 50% of the table. Then 5000 approx at 75%, and in the end we have approx 8000 occurrences. So we are having number of frequencies each at 25% level, or we can say 25% range throughout the data. So we are having number of frequencies each at 25% level, or we can say 25% range throughout the data. Therefore, from the quantile output, we can observe that 75% of the departments occurred with an estimate of 5000 times and 25% with an estimate of 8000 times. So again, we will take an average estimate of 2629 plus 5060 by 2 is 3845. Because from 0 to 25% it has 1503 times, then 25 to 50 it has 1126 times. Then again 50 to 75% it has 2431 times. So total 5060 times up to 75% of the data. Hence we'll conclude a value department which is closest to 3845. Now we will filter the data based on the frequency range from 3000 to 4000 using our base R package in a row columnar format. View the output. We can see we have store and organization department with number of occurrences 3756. Now we can conclude the missing values with storage and organization. Else we can also categorize the missing value as missing. Next, we will see how to perform transpose, rows and columns, manipulate character strings, pattern matching, replacement, and more.